We have always looked up at the sky, from the time humans lived in caves to when we built telescopes reaching the edge of the universe. We've always asked the same question: where did all of this begin? There is no whisper among the stars, no answer in the scriptures. No one was there to witness the beginning. And the most terrifying part? Maybe there was no beginning, just a moment, a singularity, no space, no time, no matter, no light, nothing. Then suddenly, everything, bursting, expanding, cooling, creating the first atoms. And billions of years later, here you are, trying to understand why. The Big Bang Theory is not just a physical hypothesis. It's the first door that opened to the universe. But for some, it's also a slap in the face of faith. How did the universe come into being? Was it really an explosion or a whisper from God? Tonight, we'll travel back to the moment when time began to flow. Together, we'll trace the stardust back to where it all started and attempt to answer one of the greatest questions in human history: how was the universe born? I've always been curious who's drifting with me through this space in the night. Now turn off the lights, take a deep breath, and come with me. Back to the beginning of everything you've ever known, and everything you've ever believed. Science and religion are in many ways opposing concepts. While one asks us to look at evidence to explain why something exists, the other asks us to believe in its existence even without evidence. This contrast is why many brilliant researchers of past generations met death before ever witnessing the results of their work. But then again, what is life if not a vessel of wonders? And so, the crossroads between faith and evidence arrived in the early 20th century with a theory made for debate, a theory that came with a bang. Why does this universe exist? What sounds like a meaningless question is actually one that many philosophers and scientists have pondered. They could hardly bear the helplessness of witnessing this vast universe existing with no apparent reason. Meanwhile, religious believers had their own answers. They said the universe was created by a god, by a supernatural metaphysical force that humans cannot comprehend. Although these two opposing ideas never truly attacked each other directly, debates between atheism and religion have always lingered, like ticking time bombs waiting to explode. However, while those bombs kept counting down, we stumbled upon an interesting discovery behind the curtain of the universe in the early 1960s. Two American physicists, Arnold Penzias and Robert Wilson, were working at Bell Telephone Laboratories in Homedale, New Jersey. This was where a large radio antenna was housed, one capable of receiving signals from the universe. With its ultra-sensitive ability to detect radio waves, this observatory allowed researchers to see through the night and uncover its secrets. And by 1965, the duo had done just that. Through their observations, Penzias and Wilson detected a mysterious radio noise, incredibly faint, yet incredibly persistent. It appeared in every observation, every signal, and every experiment, as if it were being broadcast 24/20. Initially, they thought this noise interference might come from Earth-based sources, light pollution from cities, magnetic interference from airplanes, or even nests of birds on the observation tower. However, even after eliminating all potential sources of interference, they still couldn't determine the origin of this mysterious noise. And that's when they realized the only thing that had always surrounded them and never stopped arriving was the universe itself. After comparing the findings with previous research, the duo proposed a hypothesis that the noise was a remnant of ancient radiation, residual energy from the distant past. Why was that? Fundamentally, energy once released leaves behind a trace in space, just like how a bright light leaves a lingering glare in your eyes even after you close them. And like that after-image, the trace fades over time. But the rate at which it fades corresponds to the strength of the energy source. The more powerful the source, the longer it takes to fade. And for this energy to still exist today in the form of faint radio noise, it must have come from an unimaginably massive explosion, a flash so intense it could incinerate everything. No, incinerate isn't the right word. It transformed everything into a state of excitation not gas, not plasma, but a form that modern physics still dares not definitively name. This remnant was later called the cosmic microwave background radiation. Researchers began measuring its origins and timeline. After compiling the results, they concluded it was the leftover trace of an explosion that occurred approximately 13.8 billion years ago. All of this may sound abstract and inconclusive, but to researchers this was the foundation that allowed them to peer into the past, into a study conducted more than a decade earlier, into the origin of everything, the great flash that birthed it all, leaving behind the cosmic microwave background that Penzias and Wilson discovered in 1965. And what was that study? The study of the primordial particle. Today we know that matter is composed of tiny particles called atoms. Though this advanced concept came to us only in the past few centuries, the seed of this idea dates back to ancient Greece. Around the 5th century BCE, the philosopher Democritus proposed a theory about the composition of everything. He believed that everything was made of fundamental particles, so small they could no longer be divided, calling them atomos, meaning indivisible. This idea, developed by Democritus and his teacher Luciferus, described how different arrangements of these particles would create different forms of matter. However, this ahead-of-its-time notion faced heavy criticism from other philosophers, particularly Aristotle. Aristotle believed that matter was not made of particles, but of something ever-changing, continuous and infinitely divisible. That belief evolved into the elemental theory, which claimed that all matter came from 4 basic elements: fire, air, water, and earth. But the world changed. The particle theory resurfaced and was embraced by brilliant scientists seeking to explain the world around them. It opened doors for other great minds to explore the existence of all things. One of those great minds was Georges Lemaitre. Born in July 1894 in Belgium, Georges Lemaitre grew up in a Catholic family. From a young age, he showed an exceptional talent for science and mathematics. That brilliance led him to a deep passion for math and physics. In 1911, George enrolled at the Catholic University of Leuven, majoring in natural sciences. However, before he could finish, World War I broke out, and George was drafted into the army. His time in the military didn't diminish his love for science. It gave him space to imagine future work. So when he returned from the battlefield, he immediately resumed his studies and completed his undergraduate degree. He continued on to the University of Cambridge, where he studied under Einstein's theory of relativity. Surrounded by great minds, George went on to earn his PhD in physics from MIT. But what set George apart was that he wasn't just a physicist, he was also a priest. During his university years, he was ordained by Cardinal Joseph M. Desarmes-Mercier. Thus, George became a scientist with a deep faith in God, a rare and elegant combination. In the early 1920s, this combination earned him a professorship at the University of Leuven, where he and other brilliant minds of the time studied the static universe model that Einstein had proposed in the previous decade. While observing distant stars and their redshifts, George and his colleagues realized the universe couldn't be static. It had to be expanding. Around this time, Edwin Hubble was also studying distant stars and beginning to propose the idea of an expanding universe. But, unlike Hubble, Lemaitre delved deeply into Einstein's general theory of relativity and its problems. According to Einstein, the universe functions based on gravity, or the interaction between massive particles in space-time. However, if gravity alone dictated the behavior of these particles, the universe should collapse rather than expand. Therefore, something else must be causing the expansion. George concluded that the universe couldn't have expanded as it is today without a starting point. This led him to conceptualize the idea of the primordial atom, a singularity that allowed the entire universe to expand, and he named it the indical quantum. George published this research in 1927 in a relatively obscure scientific journal called Natural. As a result, his theory received almost no attention, But everything was about to change. In 1931, Georges Lemaitre publicly presented his idea of an expanding universe, suggesting that our current cosmic system began from an incredibly dense and hot singularity. Not only that, he stated that the release of energy from that singularity would have caused a massive explosion, one that would have left behind a background radiation that we would one day be able to observe once science advanced enough. George was essentially trying to tell the world that the universe was born from a massive explosion, one that burned through space and left an indelible mark, an enduring stain on the fabric of the cosmos that we would later uncover. The existence of this theory caused many scientists to frown in skepticism. Partly, they couldn't believe that the universe was actually expanding. To them, Einstein was still right, and the universe remained eternally still. On the other hand, they didn't want to believe that the universe had a beginning, because such a notion would contradict the ideals of science, implying that something or someone must have intervened in creation. Amid these chaotic debates came Einstein's opinion, who claimed that Lemaitre's theory, though it might sound correct, was in fact utterly absurd. However, when Hubble's research on the expanding universe was published, with evidence so solid no one could deny, it drove everyone back to Lemaitre's theory of a great explosion. And when the predicted cosmic background radiation was finally observed and measured in 1965, the world no longer had grounds to refute George in his work. From there, we were left with a story about the birth of everything. The expansion of the universe confirmed a denser and smaller origin of all things. Somewhere in the past, everything was unfathomably small, unfathomably dense, denser than the core of a black hole and hotter than anything we've ever seen. This was a time when nothing existed. Time and space had not yet come into being, and everything was just a singularity, infinitely small, containing everything, yet doing nothing, because neither space nor time existed. Physics at that moment was virtually non-existent, and we cannot understand what the universe was, or how it was at that point. Then light was born. The Big Bang unleashed all the matter within the singularity, and the universe became a thick soup at an unimaginable temperature. The explosion inadvertently created two key concepts: time and space. Time had to exist for events to occur, and alongside time, there had to be space for things to exist. The immense heat of the explosion burned through space, leaving a fading mark over time. In the first collisions after the explosion, matter was released, causing the universe's density to decrease rapidly, giving particles room to move, space to move. The particles gradually slowed down, leading to the universe's cooling. In the minutes that followed, a process called nucleosynthesis occurred, allowing light elements like hydrogen and helium to form. The cooling of the universe took hundreds of thousands of years, long enough for heavier elements to form and for light to begin traveling freely through space, eventually becoming the cosmic microwave background radiation. Heavier elements later influenced space-time, creating gravity and attracting lighter elements, gradually forming large rocks, pulling together massive structures and giving birth to stars and planets. Meanwhile, the universe continued to expand, creating the future stretching of all things, the story of the creation of everything in the universe, or the Big Bang Theory, has answered nearly every question about the existence of physical phenomena in astronomy. Though many mysteries remain, such as the equation for the universe's expansion rate, this model has fundamentally proven itself, and now stands as a foundation for other great minds to continue and expand upon in the future. However, the existence of the Big Bang Theory has also caused quite a stir among many scientists, those who study the existence of all things in order to deduce laws that explain everything cannot put their faith in something that cannot be proven. It's true that we are witnessing the consequences of the Big Bang, but physics at the initial point cannot be explained, and that renders other theories nearly useless. In a way, we are unintentionally affirming the existence of God through the Big Bang Theory. Therefore, many other opinions suggest that this is not the beginning of the universe, but merely a rebirth of everything. This theory is known as the Big Bounce, the idea that everything will eventually contract and the entire universe will collapse into a singularity, leading to another great explosion in an infinite future. With this way of thinking, we do not need to acknowledge the existence of God and can still explain the presence of modern physics. But regardless of everything, the universe indeed expanding, the Big Bang remains the most reasonable explanation we currently have. Thus, the work of the priest named Georges Lemaitre still shines like a brilliant medal among the achievements of humanity's greatest scientists. Because of his discoveries, Georges Lemaitre was written into the history of space science, alongside Edwin Hubble as the co-founder of the law describing the expansion of the universe, known as the Hubble-Lemaitre law. However, being a man of inexplicable humility, George continued his life as a researcher, a professor at the University of Louvain, without caring for fame. He passed away in 1966, 1 year after his predicted theory about the universe was confirmed with solid evidence from cosmic microwave background radiation. But is the Big Bang the only time we've touched upon the concept of God in the history of science? Isn't it possible that the Big Bang is not the only evidence of the existence of some supreme being? That's the question we will answer together in the next part. And that was the story of the Big Bang theory, the controversial work of Georges Lemaitre, the priest who shook the foundations of global science to help us see the universe more clearly. What do you think about George? And are you curious to learn about the various pieces of evidence for the existence of a supreme being throughout the history of science? Let us know in the comments below. If you enjoy the content we've presented here, feel free to share your thoughts in the comments and tell us what you'd like to add. To support us, you can hit the like button and subscribe. Thank you all for listening, and see you again soon.